Quantum physics is like a magical window into the universe. Imagine peering through a telescope and seeing not just stars and planets, but the very fabric of reality itself. This branch of science doesn't just ask, what is out there? It asks, what is everything made of, and how does it all work? Quantum physics deals with the tiniest particles of the universe. These particles are so small that they are invisible to the naked eye, yet they hold the secrets to everything around us. From your morning coffee to the sun that gives us light, quantum physics explains it all. The beauty of quantum physics lies in its mystery. It's like a giant puzzle with pieces that don't always fit neatly together. But when they do, they reveal breathtaking images. This makes it both challenging and exciting for scientists and curious minds alike. So buckle up as we embark on a journey to discover the wonders of quantum physics. We'll dive into the strangest and most fascinating aspects of reality. You'll see how this science can change the way you think about the universe and your place in it. Quantum physics is the study of the smallest elements of the universe, delving into the fundamental building blocks that make up everything around us. These elements include particles like electrons and photons, which are so tiny that they defy our everyday understanding of the physical world. Unlike the larger objects we see every day, these tiny particles don't follow the usual rules of physics. They exhibit behaviors that are both fascinating and perplexing. They behave in ways that seem impossible, often defying our classical notions of how objects should act. In the world of quantum physics, particles can be waves. This means that they can exhibit properties of both particles and waves, depending on how we observe them. Imagine throwing a stone into a pond and watching the ripples. These ripples spread out and interact with each other in complex ways. Now, think of particles acting like these ripples, spreading out and overlapping with one another. They can spread out and interfere with each other, creating intricate patterns of interaction. This dual nature is a core concept of quantum physics, challenging our traditional views of matter and energy. Think of Schrödinger's cat, a famous thought experiment that illustrates the strange nature of quantum mechanics. A cat is placed in a box with a radioactive atom, which has a 50% chance of decaying. If the atom decays, the cat dies. If it doesn't, the cat lives. Until you open the box, the cat is both alive and dead, existing in a state of quantum superposition. This paradoxical situation highlights how quantum particles can exist in multiple states simultaneously. This illustrates how quantum particles exist in multiple states at once, a phenomenon known as superposition. Quantum physics also introduces the idea of probability, where the exact position of a particle is not certain. Instead of saying where a particle is, it tells us where it might be, represented by a probability cloud. It's like predicting the weather. We can't pinpoint the exact conditions, but can estimate the likelihood of different outcomes. We can't say for sure if it will rain, but we can give a probability, much like how quantum physics deals with uncertainties. This uncertainty is a key feature of quantum physics, fundamentally altering our understanding of the universe at its smallest scales. Superposition is one of the most mind-boggling concepts in quantum physics. It challenges our understanding of reality and defies our everyday experiences. It means that a particle can be in multiple places at the same time, existing in a state of uncertainty until measured. Imagine you are at a fork in the road. In the classical world, you can only choose one path. You must decide to go left or right. But in the quantum world, you can walk down both paths at once. You are in a superposition of states, experiencing both possibilities simultaneously. Picture a coin spinning in the air. While it's spinning, it's neither heads nor tails. It's in a state of superposition, embodying both outcomes. It's only when the coin lands that we see a definite heads or tails. The act of landing collapses the superposition into a single state. Quantum particles behave similarly. They exist in all possible states until observed. This is a fundamental principle of quantum mechanics. Superposition has practical applications too. It's not just a theoretical concept, but a cornerstone of emerging technologies. Quantum computers use this principle to perform complex calculations that would be impossible for classical computers to handle efficiently. While a classical computer uses bits that are either 0 or 1, a quantum computer uses qubits. These qubits are far more versatile. These qubits can be 0, 1, or both 0 and 1 at the same time thanks to superposition. This dramatically increases computational power. This allows quantum computers to solve problems much faster than classical ones, opening up new possibilities in fields like cryptography, medicine, and artificial intelligence. However, superposition is fragile. The act of observing a quantum particle can collapse its multiple states into one, a phenomenon known as wave function collapse. This is known as decoherence. Scientists are working on ways to protect superpositions to make quantum computers more reliable and robust, ensuring they can perform at their full potential. Section 4. Multiverse and string theory. Quantum physics also opens the door to mind-blowing theories like the multiverse and string theory. The multiverse suggests that our universe is just one of many. Imagine a TV with multiple channels. Each channel is a different universe. Some may be similar to ours, while others could be vastly different. String theory takes this a step further. It proposes that the basic building blocks of the universe are not particles, but tiny vibrating strings. These strings can be opened like a piece of spaghetti or closed like a loop. Their vibrations determine the properties of particles. Both theories aim to unify the forces of nature. In the classical world, we have gravity, electromagnetism, and nuclear forces. String theory and the multiverse aim to bring these forces under one framework. This is known as the theory of everything. These concepts are still theoretical. Scientists are searching for evidence to support them. If proven, they could revolutionize our understanding of reality. Imagine discovering that there are countless versions of you in different universes. It's a thrilling thought that keeps scientists up at night. Section 5. Quantum entanglement. Quantum entanglement is another fascinating phenomenon. It happens when two particles become linked or entangled in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. Einstein called this spooky action at a distance. Imagine you have two magic dice. If you roll one die and get a 6, the other die instantly shows a 6 too, even if it's on the other side of the world. That's quantum entanglement. It suggests that particles can communicate faster than the speed of light. This challenges our understanding of space and time. Entanglement has practical applications in quantum computing and cryptography. In quantum computing, entangled particles can perform complex calculations quickly. In quantum cryptography, entanglement ensures secure communication. Any attempt to eavesdrop would disturb the particles and be detected. However, entanglement also raises questions. How can particles be connected over vast distances? What does this mean for our understanding of causality and locality? Scientists are still exploring these questions. The answers could unlock new technologies and deepen our understanding of the universe. Section 6. Future applications. Quantum physics is not just a field of theoretical study. It has real-world applications that could transform our future. One of the most promising areas is quantum computing. Unlike classical computers, quantum computers can process vast amounts of data quickly. This could revolutionize industries from medicine to finance. Imagine a quantum computer solving complex problems in seconds. It could design new drugs by simulating molecular interactions. It could optimize logistics for global supply chains. The possibilities are endless. Companies and governments are investing heavily in quantum computing research. Quantum cryptography is another exciting application. It promises unbreakable security for communication. Traditional cryptography relies on complex algorithms that can be cracked. Quantum cryptography uses the principles of quantum mechanics. Any attempt to intercept the communication would be detected, making it incredibly secure. Quantum sensors are also on the horizon. They could improve everything from medical imaging to navigation. These sensors use quantum properties to achieve high precision. Imagine a GPS system that can pinpoint your location with centimeter accuracy, or medical scans that can detect diseases at the earliest stages. Section 7. Conclusion. Quantum physics is a field that challenges our understanding of the universe, pushing the boundaries of what we know. It reveals a world where particles can be in multiple places at once, communicate instantaneously, and even exist in parallel universes, defying the classical laws of physics. These concepts are not just theoretical musings, they have practical applications that could revolutionize technology and our daily lives, from computing to secure communications. The journey into the quantum realm is just beginning, and it promises to be a transformative adventure. Scientists are making new discoveries every day, each one adding a piece to the puzzle of our universe. These findings could lead to breakthroughs that we can't even imagine. Quantum computers, cryptography, and sensors are just the tip of the iceberg, hinting at a future filled with possibilities. As we continue to explore quantum physics, we'll uncover more secrets of the universe, each discovery more astonishing than the last. These discoveries will not only deepen our understanding of reality, but also open new possibilities for innovation and progress, reshaping our world. It's an exciting time to be alive as the mysteries of the quantum world unfold before our eyes, offering a glimpse into the future. In the end, quantum physics is more than just a branch of science. It's a journey into the unknown, a quest to understand the fundamental nature of everything. It's a voyage that challenges our perceptions and expands our horizons. And who knows? The next groundbreaking discovery could be just around the corner, waiting to change the world forever, ushering in a new era of scientific and technological marvels.